What could be more reliable than a belt to hold your pants up? A belt and suspenders. It's great technology, and we have taken some inspiration from that and built out two separate systems to make our prefab reliability story just as awesomely reliable as it could be. Jeffrey put together a bunch of thoughts in a blog post I wanted to call out. It's prefab global delivery. The architecture we started off with was a good and reliable system. We used Google Spanner, which has fabulous reliability uptime. We had an API on top of that we owned. And then we had a CDN using Fastly to front that. When a front-end client hits prefab, if it was a cacheable request from the CDN, we have the great CDN reliability guarantee there. But if it was not in the CDN, it would hit our API, and the reliability is only as good as the API and was a single point of failure for it. Jeffrey goes through in detail in this blog post about how we thought about this point of failure and how we thought about addressing it and the technologies that we used to solve this. We used Go and Fly.io, so we have a fully separate system, right? If you don't want a single point of failure, you need sort of fundamental resiliency. And that's why we went with Fly.io to couple our Kubernetes cluster, but have a separate system. There's some great examples in here. We walk through a scenario of what happens in cache misses here, which will go to our new global delivery network, which we call a belt. And then what happens if there were to be an issue in this global delivery network and how it falls over to the suspenders. And we work through a couple other examples like this here. We end up with these two different systems, both of which would need to go down with uncorrelated failures in order for the front-end and SDKs to not be able to evaluate a feature flag. There's also a wonderful upside to all of this is because we are now doing this in this global delivery network with Fly.io, that means that we have a much better ability to spin up a server in a local region. So previously, you can see with our sort of classic system for web hits coming from Sydney, Australia, we had a pretty slow response time of like 225 milliseconds here. But now with the new systems, it's down and it's just as fast, whether it's cached or not cached. So that is pretty awesome. We have the ability to have real much improved performance across the globe. Check out this post. Reliability and performance are a key part of a feature flag tool. So we felt really good about spending the time and energy to build out a system that is as good or really better than any of the other feature flag tools out there.